Hello everyone, myself Dr. D. Laxma Reddy from MLR Institute of Technology. Today we will discuss about the topic oscillators from analog circuits. Today we will discuss about the topics on introduction to feedback, and again the feedback is of two types. The first one is negative feedback and the next one is positive feedback, and then next we will go of our actual topic, that is oscillator, and the next what is the frequency stability of an oscillator, and finally the circuit operation of the circuit. And for this we need a detailed discussion on what do you mean by Barkhausen criteria, and finally what are the different types of oscillators. So these are the topics covered in this present video. First of all, we will see what do you mean by feedback. So feedback is nothing but the phenomenon of feeding a portion of output signal back to the input is known as feedback. For example, this is input and here we are having output. So a portion of output when feedback again to the input. So this is nothing but feedback. This is nothing but the feedback. Here what we are doing here, we are applying a part of output again to the inputs. So this process is nothing but the feedback, and this the effect is nothing but this feedback results in dependency between the output as well as input, and an effective control can be obtained in the working of the circuit. So again this feedback is of two types. One is negative feedback and the next one is a positive feedback. First of all, we will see what do you mean by negative feedback. In the negative feedback, the feedback energy is out of phase with the input signal and thus opposes it. That means whatever the feedback signal that we are giving from the output, here we are using negative feedback. Okay, so when when the input and this feedback signal is out of phase, when these both are out of phase, then we can call it as negative feedback. And mainly this negative feedback will used in amplifiers, and the use of this negative feedback is it will reduces the gain of the amplifier, and as the gain of the amplifier reduces, it will also reduces distortion, noise and instability of the signal. So and moreover this feedback signal will increases the bandwidth, and hence we can improve the input and output impedances. So due to this above advantages, the negative feedback is mainly used in amplifiers. So the negative feedback amplifiers is used in amplifiers. So this is the main advantage of negative or degenerative feedback. Coming to the second feedback, that is positive feedback. So in this positive feedback, what we are doing, this feedback signal is in phase with the input signal. This is the feedback signal. So here the feedback signal and the input signal are in phase. So we can call it as positive feedback. So with the help of this positive feedback, it will increases the gain of the amplifier, and hence it will increases the distortion, noise and instability. So due to this disadvantage, positive feedback is not used in amplifiers. So where we will use this? We will use this positive feedback in oscillators. So this is the advantage of positive feedback. Negative feedback is used in amplifiers and positive feedback is used in oscillators. So remember, this is most important. Negative feedback is mainly used in amplifiers and positive feedback is used in oscillators. So oscillators is nothing but the topic what we are going to discuss in this lecture. So first of all, what do you mean by oscillator? So an oscillator is nothing but it is an circuit or electronic circuit that generates an output signal without the necessity of input. So without any input, we will get output signal. Just we will give a DC voltage, and here we will get the output. So there is no need of any inputs. So such type of circuit is nothing but oscillator. It produces a periodic waveform on its output without only the DC supply. So this is the DC supply what we are giving. So it will produces a periodic waveform. So periodic waveform is nothing but a sine wave, a square wave or a sawtooth waveform. and the output voltage can either be sinusoidal or non-sinusoidal depending upon the type of oscillator. So depending upon the type of oscillator, the output may be sinusoidal or non-sinusoidal. So there are different types of oscillators, so we will come across in the further slides. And this is the block diagram of oscillators. See what we are doing here, we are having a feedback network. So this is the feedback network, and as this is a block diagram of oscillator, so what type of feedback we want to use? We want to use positive feedback. See here we will use positive feedback. So this is the amplifier circuit where we are giving the DC supply, and here we will get the output, and this is the oscillator circuit. So depending upon this oscillator circuit, we can get any sinusoidal or non-sinusoidal. So this is the basic block diagram of an oscillator. See here we are having only the output and DC supply. There is no input. There is no input signal. So as this oscillator definition is nothing but without any input signal, with the help of only the DC supply, we will get the output signal. In order to understand in detail about the oscillator, first we want to know what do you mean by frequency stability of an oscillator. So the frequency stability of oscillator is nothing but it is a measure of its ability to maintain a constant frequency over a long time interval. So what do you mean by this? This is very important point. So what do you mean by this? We want to maintain a constant frequency over a long time interval. As we have seen in the sinusoidal output, so this is the sine wave what we want to expect. But as this is the time domain, as the time increases, okay, the amplitude of the signal may decreases. The amplitude of the signal may decreases. So in order, as this decreases, then there will be no output. So what we want to maintain here, we want to maintain the frequency stability. That means the frequency of the signal should be maintained constant throughout the output. So this is nothing but the frequency stability of an oscillator. So how you can define the frequency stability of an oscillator? The frequency stability of an oscillator is nothing but it is a measure of its ability to maintain a constant frequency over a long time interval. So here we can have only this time t1, only within this time duration only we are maintaining a constant frequency. After that we are seeing in the time the frequency of the signal is going on decreasing in the time interval t2. So we want to maintain a constant frequency throughout this interval. Otherwise the signal strength may be decreases. So when we are operated over a long period of time, the oscillator frequency may drift. Drift means it will vary. It may decrease or it may increase. So it can happen like this also. See now. So this is, so we should not get like this or we should not get like this. So we should maintain a constant frequency throughout the time period. So what happens if we increase or if we decrease or increase in the output frequency after a certain time duration? What happens if the time or if the frequency is increased or decreased? So here we can have three effects. Why this is going to happen? That may be increased or decreased. So this may be happen due to three reasons. One is any deviation in the operating point of the active devices, that is in the oscillator circuit we are using amplifiers. So in the amplifiers we are using active devices like BJT or FET. So if any deviation in the operating point of the BJT or FET, that may result in this drift in the frequency. So this is one of the reason that when the operating point of the device, that is BJT or the FET, when the operating point is varied, it may be increased or decreased, then the stability or then the frequency stability of the oscillator may vary. That is one of the reason. And the second one is the change in DC supply voltage. As we have discussed in the oscillator circuit, we will maintain one DC supply. So if there is a change in DC supply, then there is an drift in the output of the frequency. So this is the second effect. And the last one is, if there is a change in output load, it may also results in the output frequency may vary. If there is the output of the load may change. If the output of the load may change, then the oscillator output frequency will also change. So these are the three main reasons, or three main reasons to drift in the output frequency, or the frequency stability of the oscillator may vary due to these three reasons. The first one is any deviation in the operating point, the second one is any change in DC supply, and the third one is any change in the output load. So we want to make sure that these three should be constant throughout this circuit operation. Now we will see what is the exact circuit operation of the oscillator. So here we are using an amplifier where we will use the active devices like BJT or FET, and this is the input signal where we are applying with the source. It is denoted as Vs. Vs is the input signal. Vs is the input signal. Here we are applying, and Vi is the input signal that is applied to the amplifier, and V0 is the output of the amplifier, and a portion of the output signal is giving back again to the input. This is nothing but the feedback network. So beta, we are having a feedback network beta, and feedback voltage Vf equal to beta into V0, whatever V0 we are taking here, beta into V0, and this we are again giving into the input. So Vi is the input before feedback, and Vf is nothing but after the along with the feedback signal. So Vf is nothing but the feedback voltage. So a portion of the output signal, see here we are taking back again to the input. Okay, so here Vi is the input applied at the terminal of the amplifier. So here Vi is the input to the terminal of the amplifier with gain A. So what is the gain of the amplifier? A. And here the feedback network has a feedback fraction beta, and the output of the voltage is V0. We are represented by V0, and the feedback voltage is represented by the letter capital V suffix F. So this is the feedback voltage. So as for a as we seen that for the oscillator, what type of feedback we are using? We are using positive feedback. So what is the at the input Vi? Vi is nothing but Vs, the actual input, and feedback voltage Vf. So as it is a positive feedback, Vi is nothing but input to the amplifier is Vs plus Vf. So we are having Vi equal to Vs plus Vf. And what is Vf? Again from the circuit we can see Vf is nothing but beta times of output voltage V0. So substitute here Vf is nothing but beta into V0. So finally what we are getting? Vi equal to Vs plus beta times of V0. And the output voltage V0 must be equal to the input voltage. Yes. So here from the circuit, what do you mean by V0 voltage? V0 is nothing but the input voltage Vi multiplied by the gain of the amplifier A. So V0 equal to Vi times of A. So from this V0 equal to Vi times of A. So what is Vi from here? Vs plus beta times of V0. So just we will simplify this. From this Vs equal to V0 minus AVs equal to V0 minus beta times of V0 into A. Just move this term to the right hand side. So here AVs equal to, take V0 as common, so 1 minus beta times of A, right? From this V0 by Vs equal to A by 1 minus A beta. What is V0 by Vs? Vf, feedback voltage, equal to A by 1 minus A times of beta. So this equation will use for the derivation of Barkhausen criteria. We will see what do you mean by Barkhausen criteria in the next slide. So understand this. So first of all, we are getting from the circuit what is Vi. Vi is nothing but the sum of input voltage Vs plus the feedback voltage Vf. So we are getting Vi equal to Vs plus Vf. What is Vf? Beta times of V0. Beta is nothing but the feedback network. Feedback fraction, sorry, beta is nothing but feedback fraction. So substitute in place of Vf. So what you will get, Vi equal to Vs plus beta times of V0. So beta times of V0. So when you are calculating the output voltage V0, V0 is nothing but the input voltage Vi times of the gain of the amplifier. What is the gain of the amplifier from the circuit? A. So Vi times of, so here V0 equal to Vi times of gain of the amplifier A. So here Vi is nothing but Vs plus beta times of V0. So substitute here. So after simplification, we will get Vf equal to A by 1 minus A beta. Remember this equation. Next, Barkhausen criteria. So in the previous slide, we have derived that Vf is nothing but A by 1 minus A beta. So this is the closed loop gain of the positive feedback. So AF is nothing but, sorry, here not Vf, AF. AF is nothing but the closed loop gain of the positive feedback. So it is denoted by A suffix F, that is nothing but A by 1 minus A beta. When this A beta, when this term A beta is equal to 1, what we will get? AF equal to A by 1 minus 1. So 1 minus 1, 0. That is AF equal to infinity. That means the gain will becomes how much? Infinity. So this indicates that there is an output without any input. Without any input. So that states the definition of oscillator. So what do you mean by oscillator? Without any input, we will get the output. So from this equation, when this term A beta, A into beta is equal to 1, we will get this feedback factor AF as infinity. So from this expression, we can tell that there is an output without any input. So we can tell that, therefore this condition, that is A beta equal to 1. So this condition states that under this condition we can tell that an amplifier at this condition, that is A beta equal to 1, at this condition it works as an oscillator. Therefore we can tell that amplifier in this condition is nothing but when A beta, the fraction of feedback fraction beta and the gain of the amplifier is equal to 1, then we will get the output as infinity. Okay, so from this expression we can tell that the amplifier can act as an oscillator under which condition? A beta, the product of A into beta equal to 1. So this condition A beta into 1 is called as Barkhausen criteria. So this is the satisfying, this is the condition to be satisfied to work the circuit as an oscillator to produce sustained oscillations at constant frequency and amplitude. So in the previous slides, we have seen that due to the variation of operating point or the change in DC supply or change in the output load, there will be a frequency drift. So in order to overcome this, what the condition we want to maintain? We want to maintain the condition like the product of A beta should be equal to 1. So this condition is called as Barkhausen criteria, and this condition will satisfy to operate our circuit as an to work our circuit as an oscillator. Okay, so this is very important, Barkhausen criteria. What do you mean by Barkhausen criteria? A beta should be equal to 1 or A beta slightly greater than 1, not more than, slightly greater than 1 also, it will satisfy this condition. Next we will see what are the different types of oscillators. So based on there are different types of oscillator, mainly tuned oscillators and untuned oscillator. Under the tuned oscillator we will have the first RC oscillator, LC oscillator, crystal oscillator and multi-vibrator. Under untuned oscillator we will have relaxation oscillator and ring oscillator. So in our syllabus we are having RC oscillator, LC oscillator, crystal oscillator, and RC phase shift oscillator, and Wien bridge oscillators. So these are these 5 oscillators comes in our syllabus. So this regarding this oscillator we will see in our upcoming videos. So finally I will conclude like, first of all we have seen what are the different types of feedback, that is positive feedback and negative feedback. Positive and negative feedback. Positive feedback are used in oscillators and negative feedback is used in amplifiers. Next we have seen the definition of oscillation. Oscillator. Oscillator is nothing but which will produce, it is an electronic circuit which produces output without any input, only we can supply only the DC voltage. And the next, frequency stability. We have seen frequency stability and circuit operation of oscillator, and next we have seen what? Different types of oscillations. So this different types of oscillation we can see in the upcoming videos. Thank you.